Hi, you're here with Mr. Canada, and we're looking at the division law of the law of indices. So here, stated this before, x to the m divided by x to the n, where m and n are just two numbers, and x, well, it doesn't matter what x, it could be x, it could be y, it could be z, it could be 1, it could be 2, it could be 3, doesn't really matter what x is either, as long as x is something, that's the same. So we find that by doing x to the m minus n, and that's because if you look at simply here, the division sign kind of looks like, hey, let's replace this x to the m, or dots with this, and that also looks kind of like a minus sign in the middle, so we'll subtract, right? So just kind of ways to just remember what the laws are. I always say if you can remember the multiplication or the division, you'll find the other one eventually. But what does this actually mean? Well, it means that we can simplify their indices. So if we have a to the 5 divided by a to the 4, we can write this out in the long version as a times a times a times a times a on the top, and on the bottom, a times a times a times a. Now, we know that if we cross out one on the bottom, one on the top, right, something over itself is just 1, so we can keep doing that as we go along. And we'll find that there's just a whole bunch of 1's times together, and we'll have this last a. So all 1 times 1 times 1 times 1 times a is simply just a. So we can see also that we could just do a to the 5 minus 4, which is a to the 1, which we state as just a. So we have a special case. You do not have to know where this comes from, but I like to show you anyways. Just remember that anything to the power of 0, doesn't matter if it's 2 to the 0, 3 to the 0, x to the 0, right? These are all going to be equal to 1. So the reason why is just from this division law. So if you set up a divided by a, right, and you set it up like we did over here in black, then we find that, well, that's 1 minus 1, which is a to the 0. Okay, but a is, we can also say that as 1 over a, right? Oh, sorry, that should be a over a is 1. My apologies, right? So that's a divided by a as well, and that equals 1. So therefore, a to the 0 has to be equal to 1 in every other case. So you don't have to know, you just have to be able to say anytime you see it, oh, I know that's just a 1. So let's actually work with some examples. So we have x to the 5 divided by x to the 3. So check if the bases are the same. They are. Next part, x to the 5 divided by x to the 3. So we can go to the x to the 5 minus 3, which is simply just x squared. So let's look at something a little bit more challenging. We're not just subtracting the powers. So here, we're going to treat it as 4 divided by 2. And some people actually like writing this out the more algebraic form. And I'm one of those people as well because it's more proper for one and easier for another. Okay? So let's just look at our first one. So what's 4 divided by 2? That's 2. X to the 6 divided by x to the 3. Well, x to the 6 minus 3 is x to the 3. Right? So we get 2x cubed. One other thing that we could start to do is 64 divided by 8. Well, that's just 8. Then we can do x cubed. So 3 minus 1. And then it's to the y of 2 minus 2. So we're going to get 8x squared, y to the 0, which is simply 8x squared. So it looks very different, very simplified in comparison to what we had. So here is a variety of expressions for you to give a go at. 9 different questions. The first 3 are quite straightforward. Then the next ones have to do with some numbers in there. So if you can, evaluate. And then the last ones are as such. You do not have to actually evaluate, but if you'd like to, go right ahead. I probably will choose to go do some when I go through it. Okay, so we're back. X squared divided by x, that's just going to be x. Well, 7 minus 2 is y to the 5. C squared divided by c is just c, because 2 minus 1. Negative 4 to the 3 divided by negative 4 to the 1. So 3 minus 1 is, we're going to get negative 4 all squared, which is 16. 17, 13 divided by 17 to the 3 is equal to 17 to the 10. And I could write that one out, but we're actually going to have to write it in something called standard form that we may not have gone over quite yet. So here we have 2 divided by 1 is 2. And then we have to look at our indices. X squared divided by x squared. Well, that's x to the 0, which is also just equal to 1. So our answer is just 2. So this is why we simplify, because sometimes all of our variables might just cancel out and we'll be left with just numbers, which is quite nice and can be used. So 81 divided by 9 is 9. 5 minus 2 is 3. Here, 16 divided by 8 is 2. X to the 3 minus 5. So we're going to get 2x to the minus 2. Here's another one of those negative powers that we keep running across. I wonder what's going to happen. Here, well, 24 divided by 16 is not too nice, but we can kind of simplify this. What else goes into 24 and 16? I know 4 does, so I'm going to say divide by 4 on top, so that's 6 over 4. So we got closer to simplifying it, so that's great. You don't have to do it all in one step. Here, we're going to be left with x on top, and then y to the 5, right? So we can simplify this, and it'll be at 3 halves x y to the 5th.